在月球的背面，地球的自转跟月球的自转是同样。
Vision is one of the principal methods we've used to explore our surroundings since birth. Since ancient times, people have aspired to look at the world from a higher position, from further away, from different angles and perspectives. However, nowadays, few have had the chance to actually fly into space and view the Earth's surface, other than a handful of astronauts, till it came along. 1,600 times taller than the Taipei 101, 80 times faster than a Ferrari. It can survey vast dimensions and acquire extensive measurements in an instant. Day and night, it takes not a moment's rest, guarding our world 24/7. It is the remote sensing satellite. Remote sensing refers to observing and sensing an object from a distance, without making physical contact. Just as we view the scenes before our eyes, the eyes of the satellite are high-precision sensors which observe surfaces from remote distances. And that's why it's called a remote sensing satellite. This is an image acquired by a satellite from an altitude of several hundred kilometers. The multispectral sensor in satellites is a high-tech product. In addition to visible light, it also detects near-infrared, thermal infrared, microwave, and radio wave. These electromagnetic radiations are invisible to the human eye. Therefore, it can see much more than our eyes are capable of. For example, from the bleachers of a ballpark, it is difficult to distinguish between a natural and an artificial grass field with the naked eye. This is because natural grass and artificial grass have similar energies within the visible spectrum. They all look green. There does not seem to be much difference. But at near-infrared frequencies, natural grass delivers an energy much greater than artificial grass. This is how the satellite's multispectral sensors are able to distinguish between them. Sunlight is the main source of electromagnetic waves from objects detected by remote sensing satellites. When sensors passively receive solar energy reflected from the surface of an object, it is called passive remote sensing. At night, or in bad weather conditions, when sensors on satellites voluntarily emit energy, such as radar, it is called active remote sensing. Radar has excellent penetration capability, allowing it to easily penetrate obstructions like clouds, smoke, or dust to reach ground surfaces and be reflected, and then detected by satellites. In this way, large-scale terrain data can be provided throughout the day. Satellite radars measure by scanning with radio waves. The phase and amplitude data brought back by radar echoes have superior coverage and precision. A satellite in orbit has a predetermined course and observation cadence. It passes over the same target area every once in a while. As such, it is able to repeatedly compare observations within a short period of time. Located in the Center for Space and Remote Sensing Research, National Central University, researchers are interpreting satellite radar images taken before and after the 9/21 earthquake. Deformations in the land surface lead to changes in the distance between the surface and the satellite and cause differences in radar phase. Researchers often paint phase changes in different images with colors of the rainbow to generate an interferogram. Circular fringes in the interferogram reflect the extent and scope of surface deformation. By comparing our interferograms before and after the 9/21 earthquake, we noticed that a large number of fringes appeared around the Cholongpu Fault, which are marked by a black line. Each circle represents a deformation of 2.8 centimeters. From this, we can calculate that the center of fringes, or the location with maximum deformation, has a subsidence of about 30 centimeters. Satellites orbiting the Earth not only enable us to observe the surface, but also to fully grasp all kinds of atmospheric phenomena. In the past, collection of atmospheric data mainly relied on ground stations, but there are many areas on Earth, such as oceans and polar regions, where ground stations are rare. Satellite data covers these gaps precisely. Satellites are able to observe atmospheric phenomena thousands of kilometers away. Many meteorological changes can be seen on the cloud atlas as they develop. Besides utilizing the satellite cloud atlas to analyze various weather systems and monitor rapidly developing storms, precise sensors on the satellite may also obtain information that was previously impossible to obtain with traditional instruments, such as using microwave and infrared images to analyze cloud type and height and calculate the temperature of ground and water surfaces. Satellites which carry rainfall radars provide better rainfall monitoring to help us make more accurate weather predictions. From astronomy to geography, the comprehensive coverage of satellites provides abundant and powerful information. It also allows us to see. Let creativity stimulate endless possibilities in satellite technology. Researchers in the Center for Space and Remote Sensing Research use a mouse to navigate freely between buildings and streets on screen. This is a so-called digital city. Just like 3D virtual worlds in modern movies and games, the realism of the experience keeps our eyes glued. But unlike movies and games, this world is not just imagined, but consistent with the real world. To build a digital city, first, satellite images or navigational maps are needed as a base on which 3D housing models are built, in coordination with terrain contours. Next, apply wall textures one by one, correct image geometry, and integrate these properties. All figures used in the digital city conform to reality as much as possible. Therefore, this 3D virtual reality created matches the real thing in shape and size. This is a building which will undergo urban renewal. Although reconstruction has yet to commence, through the architectural plans, we can already see what the result will look like in this digital city. Through this, we can determine whether or not this new building will match the existing landscape. Exterior colors can be applied freely to help our judgment. Even sunlight on the building can be simulated to see the extent of shadows and their impact on the surroundings. Everything is true to life, and thus all the more convincing. The satellite quietly gazes at this beautiful planet. Overlooking this world from hundreds of kilometers away, horizons widen, voices disappear. The tranquil land appears harmonious and beautiful. Perhaps it is impossible to see the complete picture of everything, but by observing and thinking from different viewpoints, different angles, you will see a different world.